Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is important concepts of representation of data. An important advice for me and for everyone: we should be fair to others. Statistics. It is a subject that deals with collecting, organizing, summarizing, presenting, and analyzing data. The collection, organization, and analysis of numerical information are all parts of the subject called statistics. Data. Data means pieces of numerical and other informations. Qualitative variable. A variable is qualitative if it is not possible for it to take a numerical value. Quantitative variable. A variable is quantitative if it can take a numerical value. Continuous variable. Continuous means measurable quantities. Any quantitative variable which can take any value in a given range is continuous. For example, time. If t lies between 1 and 10, then t can take any value from 1 and 10, whether the value is whole number or decimal. Like t can take 0.5, t can take 1.2, 1.5, 2.3, 9.8, and so on. And integer values as well, 7, 8. Discrete variable. Discrete means countable quantities. Any quantitative variable which has clear steps between its possible values is discrete. Like integers, like number of heads on when a fair coin is tossed 10 times. So 0, 1, 2, and so on. For example, x, if x is discrete, so it can take any value from 0 to 10 when a fair coin is tossed 10 times. So x means number of heads. So we can have no head, we can have 2 head, we can have all 10 heads. So x is integer, meaning x is discrete, countable quantities. T is continuous, x is discrete. T is measurable and x is countable. That's the meaning of continuous variable and discrete variable. Diagrams for ungrouped data. To represent ungrouped data. Well, we have two diagrams to represent ungrouped data in our syllabus. Number one is stem and leaf diagram. In short, you can say this is stem plot, and box and whisker plot. In short, this is also known as box plot or 5-number summary. Stem and leaf diagram, we call this, in short, we call this stem plot. And box and whisker plot. Box and whisker plot, the other name of this diagram is 5-number summary, or in short we can call this as box plot. Stem plot. The advantage of a stem plot is it shows all the data. The original information has retained in this diagram, and this is the only diagram in which the original data has retained, and you lost your original data in all the other diagrams. So when data is small, then stem and leaf diagram is a suitable way to represent the data because it shows all the data. And it tells the type of the distribution, whether the distribution is symmetrical or non-symmetrical. Box and whisker plot or 5-number summary, or in short box plot. This 5-number means lowest observation, Q1, median, Q3 and highest observation. These 5 observations are known as 5-number summary. Advantage of box plot. Box plot tells the type of distribution, like the distribution is symmetrical or non-symmetrical. It shows the scatteredness as well, like the observations are more scattered or less scattered from their mean. High range means more variation and low range means less variation. There are 3 different types of box plot. Number 1, positively skewed. When median is closer to Q1, then the box plot is known as positively skewed, like this. And when median is closer to Q3, then the box plot is known as the negatively skewed. And when median is at the center, then box plot is symmetrical. The distribution is symmetrical. And range, the formula of range is highest observation minus lowest observation. So we have 2 diagrams to represent ungroup data. Number 1 is stem plot and number 2 box plot. Stem plot. I told you stem plot shows all the data. It shows all the data, number 1. Number 2, it provides an easy way of organizing data. These are the advantages. A way of organizing the values that gives some information about the patterns within the data, like data is symmetrical or non-symmetrical. Value is split into 2 parts, namely a stem and a leaf. This is stem and this is leaf. Leaf is always single digit. We can have 2 or 3 or more digits in a stem. If data is large, a stem diagram is not the best method of displaying data because we need to use other, and so we need to use the other methods. And the best advantage of this diagram is it shows all the data. We will discuss histogram and cumulative later. I'm just focusing on stem plot and box plot. Box plot. We can convert a 5-number summary into a useful diagram called a box plot, box whisker plot, or just box plot. 5-number summary, I already have told you 5-number summary means the median, the lower quartile, the upper quartile, the minimum value and the maximum value. Skewed distribution. Well, if a distribution is not symmetrical, this is the symmetrical distribution and this is the non-symmetrical distribution. So if a distribution is not symmetrical like this, then it is said to be skewed or to have skewness. So this distribution is skewed. And when distributions are symmetrical, then they have 0 skewness. Since this distribution is symmetrical about mean, we have equal area on left side and right side, and this is the line of symmetry. So this distribution is symmetrical and this has 0 skewness. This distribution is non-symmetrical. And we have mode here at the lower side. The peak is here, so mode is here, and we have long stretch tail towards higher values. So this distribution is positively skewed. So distribution is certainly not symmetrical, this one. There is a tail which stretches towards higher values. Another method of assessing the skewness of a distribution is to use quartiles. There are 2 methods to understand the skewness. If we have a long tail stretches towards higher values, then distribution is positively skewed. This is the first way. And the other way is this. If if median is close to Q1, right now median is at the center. In this case, median is at the center and we have equal, almost equal, but this one is shorter and this one is longer. So this, you can say this one is approximately symmetrical or almost symmetrical. When we have equal magnitude of whiskers and when median is exactly at the center, then the distribution is perfectly symmetrical and that will follow the normal distribution. But this box plot is approximately almost symmetrical because we have a shorter whisker here and longer whisker here. So this is approximately symmetrical. So when median is at the center, when we have equal area on right side and left side, then the distribution is perfectly symmetrical, and for that distribution, mean, median, mode all are equal. Mean is this line, mean is here, median is here, and mode is also here. And see, median is at the center and we have equal lengths of whiskers. So this distribution is perfectly symmetrical. This has zero skewness. This is the positively skewed. So in positively skewed distribution, the fall of the distribution is pulled in positive direction. Here. Well, when you can understand this concept through this, this thing. The box of this distribution is here. So to understand the positively skewed distribution, you should look at the median. If median is close to Q1, then the distribution is positively skewed. So in positively skewed distribution, we have two things. Q2 is closer to Q1 and we have long stretch tail on right side. So there are two ways to identify the positively skewed distribution. Number one, median. If median is close to Q1, then the distribution is positively skewed. And the other way is, if we have long stretch tail towards the higher side, then we can say that the distribution is positively skewed. Positively skewed means low averages. And negatively skewed is the opposite of positively skewed. Then median will be here. So when median is close to Q3, then the distribution is said to be negatively skewed. And we have long stretch tail over here. So there are two ways to understand this concept. I usually use median. I observe median. If median is close to Q3, I can easily identify the distribution is negatively skewed. And when median is close to Q1, then I would say this is the positively skewed. And when median is exactly at the center, then I would say that distribution is perfectly symmetrical and with equal length of whiskers. Well, we use box plot to identify the type of distribution. When we have just one box, now this is very important. Now this concept is extremely important. When we have just one box, then how would we check the distribution? How would we comment the distribution? So when we have just one box, then we observe the median. Since median is approximately at the center, not exactly at the center, so we can say that this box plot gives an immediate impression of an approximately symmetrical distribution. Since median is not exactly at the center, therefore you should say this box gives an immediate impression of an approximately symmetrical distribution. This distribution is approximately symmetrical. But this distribution is not approximately symmetrical because in this distribution, Q2 is close to Q1. So when Q2 is close to Q1, that means the positively skewed distribution. So this box gives an immediate impression of a positively skewed distribution. So when we have just one box, then we state the type of distribution. But when we have two boxes, like in this case, then we have to give two comments. We usually give two comments, and one comment with respect to median and one with respect to range. So whenever you have two box, make sure you comment and the type of distribution uh, with respect to median and with respect to their ranges. So whenever you say with respect to median, then you have to say on average. Must write on average. So the first comment is according to median, and this labeling will tell you the quantity. So length of insects in centimeter. So you would say y, since the median of y is greater than the median of x, so you would say y has longer insects on average. In other words, you can say on average y has longer insects than x. This is the first comment with respect to their median. Now the second comment would be with respect to their range. Their ranges, in fact. So y has longer range than x. So you would say y has longer range than x, or you can say uh, more spread in length of y, type y insects than type x insects. More spread. Another example, the box plots show the distributions of marks obtained by a class in English and in mathematics. Comment on the distributions of marks. Now you can comment in two ways. There should be two comments. Number one, they ask just comment. So we can just comment according to their ranges. But if they ask comments on the distribution of marks, then you have to give two comments. I'm giving two comments. Number one, I'm giving comments with respect to median. See, the median of math marks is greater than the median for English marks. So you can say on average, students have performed well in math test than in English test. On average, students have performed well in math than in English exams. Range is greater in English. So you would say more variation in English marks than in math marks. Or you can say marks are more spread in English than in math. English marks have a wider range than math marks. Or you can say marks are spread out in English than in math. So these are the ways to uh, comments the type of distributions in box plots. Now the next topic is outliers. Outliers means abnormal data values. So abnormal data values are known as outliers. Sometimes unusually high or low values occur in a set of data, and those values are known as abnormal values. There may be good reason for these unusual results, but quite often they occur because an error was made when the data were recorded. To investigate extreme values, you would use the mean and standard deviation or the quartiles and interquartile range. We usually use interquartile range. So to to investigate those values, we have to use interquartile range, and we have to get the boundaries for the data. And outside those boundaries, the data values are known as outliers. This is the upper boundary and this is the lower boundary. And outside this boundary, we have two observations. So these are two outliers. So if any data value would lie outside these two boundaries, then that value or those values would be considered as outliers. And how would we get these boundaries? The formula for these boundaries are here. The formulas are here. Number one, for upper boundary, use this formula. Q3 plus 1.5 IQR. This is the formula for the upper boundary. And for lower boundary, use this formula. Q1 minus 1.5 IQR. See, this is the IQR. So upper boundary is 83.5 and lower boundary is 55.5. So two observations are outside from these two boundaries. So these two observations are considered as outliers. So outliers means abnormal data values, unusual data values. Now let me explain histogram and cumulative, and then we will go to understand these solutions of important questions. Diagrams for group data, for continuous group data. For ungrouped data, we just have done two diagrams, box plot and stem plot. And for continuous group data, we have two diagrams. Number one, histogram, and number two, cumulative frequency graph. We use histogram to check two things. Advantages of histogram. Histogram basically tell us two things. Number one, the modal class. We can easily get the modal class from histogram. These are the advantages of histogram. So from histogram, we can easily get the modal class. And number two, we can understand the type of distribution, whether the distribution is skewed or symmetrical. Labeling. On horizontal axis, we label class boundaries, and on vertical axis, we take the frequency densities. Cumulative frequency graph. We use cumulative frequency graph to get two important things. Number one, median. Number two, IQR. And number three, percentiles. And number four, we can estimate the any value, like for example, we can estimate, for example, like this. If we have, this is cumulative frequency graph. If we have marks here, and if we have number of students are here, so we can estimate the number of students who have got more than 70 marks. So we can estimate anything from cumulative frequency graph. So cumulative frequency graph is a really good way to estimate the things from graph. Well, graph. The word graph means either draw cumulative frequency curve or either draw cumulative frequency polygon. You have two options, either go for curve or polygon. Curve means like this, and polygon means join the corresponding point by means of straight lines. The labeling for horizontal axis for both the diagrams are same. We take class boundaries on horizontal axis, either both for histogram and cumulative, and we take cumulative frequency on vertical axis for cumulative frequency graph, and we take frequency densities on vertical axis for histogram. Well, histogram, a bar graph which represents continuous data. Number one, bars have no space between them. Area of each bar proportional to frequency. When group frequency distribution contains continuous data, one of the most common form of graphical display is a histogram. In a histogram, if all bars equal width, then height is proportional to frequency. When a group frequency distribution has unequal class, then we take frequency density on vertical axis. We have two types of data, group data. Number one, discrete, and number two, continuous. Marks means discrete and length means continuous, because marks are countable and length means measurable. So this is the discrete. So whenever we have discrete, we go for class boundaries. And this is the continuous, so we don't need to form class boundaries. We form class boundaries when we have different values here and here. And we basically form class boundaries to make these two values same. Now we have same values. Here we already have same values, so there is no need for class boundaries. You can consider this as class boundaries. This question can come in your exam. Uh, Explain why mean and standard deviation are estimates rather than the precise values. We use these formulas for mean and for variance or standard deviation. This is for variance, sigma f square, sigma f. We just did this in first lecture, and this is for mean. So this x means class centers. Basically, whenever we find mid values, so mid values basically uh, representative of the intervals. They are estimates. So individual values are not known. So mid values have been taken as representative of the intervals. Like for example, this interval is 1 to 10, this is from 11 to 20, this is from 21 to 29, and so on. And the frequency is 5, 7, and 8. So the mid value will be 5.5. So we are considering that 5.5 is repeated 5 times. We are estimating, we are assuming, which is not true exactly, because there must be other values which will be repeating. Here we are assuming that 15.5 is repeating 7 times. Just 15.5 is repeating 7 times, which is not right. So whenever we use this formula and we take class centers or mid values, then this x is representative of the class interval, and this x is basically estimate. So let me write this here. Because the use of class centers is an approximation. That therefore we get estimates, we don't get precise values. Since the class centers are approximation, therefore we can only get the estimated answer. I will explain this concept in a question, inshallah. In a question of this type. Well, number one, we have to construct the stem plot. Now, how to construct this stem plot? This is very simple. The data is in 3 digits, so you should assume that this is also in 3 digits. So you need to take 0 common. See, we have 0 in the whole data. So you can just make a scale or take a scale, use a scale. Just take a 10 common. You will mention that 10 in the unit later. So you should assume this data is 57, 45, 31. This is just 1 or 0, 1. So the lowest observation is 0, 1, and the highest observation is 57. Let me write this here. 0, 1 is the lowest and the highest is 57. This is stem and this is leaf. The section for leaf, and this is the section for stem. So 0 to 5, this is the range of values for stem. 0, 1, 2, 3, 4, 5. And for leaf, no problem. You can just directly just cancel the numbers and list the numbers here. Now, how to make this stem plot? Number one, first write the range of values of a stem by considering the smallest and largest values of the data. Now, the smallest is 0 and the largest is 57. Now, cancel this value and write 1 here. 44, 66, 8, 100 means this is just 10 basically. So 0, 13 and so on. In the key, you have to mention this thing. 1/0 means 100 because the scale is 10. These values are nearest to 10. So 1, 0 means 100, meaning you will read this value as 200. Meaning 3/1 means 310. Now, how will you get a median, lower quartile, and upper quartile? I told you the formulas in my first lecture. The formula for median is n plus 1 upon 2th observation. This is the formula for median for ungrouped data and for odd number of observations. And in fact, we use the same formula for even number of observations as well. So we have 27 observations. When you will put 27 here, it will become 28. 28 upon 2 is 14. So check the 14th observation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is the 14th observation. So you will read this as $160. Make sure you must write the key with unit. Lower quartile. This is the odd number of observation. These are the number of observations. So the formula for lower quartile will be Q1 1 upon, you can write this as n plus 1 upon 4th observation. So 28 upon 4th, which is 7th observation. This is the 7th observation. And for upper quartile, use this formula, 3 upon 4 n plus 1th observation. 21st, just check the 21st observation. And interquartile range is Q3 minus Q1. Well, upper boundary for outliers. This is for outliers. The formula for upper boundary is this. Q3 1.5 IQR. And the formula for the lower boundary is Q1 minus 1.5 IQR. So the upper boundary is this and lower boundary is this. Now check the outliers. So outside this range, 35 and 315. So this is the outlier, this is outside 35, and these are two outliers because these are greater than 315. So there are three outliers. This was the last part. An outlier is defined as 1.5 times above the upper quartile. This means Q3 plus 1.5 IQR. And 1.5 times below the lower quartile. This means Q1 minus 1.5 IQR, which is here and here. So we have found the boundaries for outliers, and there are three outliers. List the outliers means these are three outliers. Now you can view this solution, and you can take the screenshot of the solution now. Now we have this data, and we have this is the data for history exam, and this is for physics. Now number one, we have to arrange this data in ascending order like this, and then we have to find 5 informations: the lowest observation, the highest observation, median, Q1 and Q3. Since data is odd in number, so the formula of median is n plus 1 upon 2th observation. So since we have 13 observations, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 14 upon 2, which means 7th observation. When data is arranged in ascending order, 1, 2, 3, 4, 5, 6, 7. This is the median. And lower quartile. The formula for lower quartile is 1 upon 4 n plus 1th observation. That should be 3.5th observation. 3.5 means the average of 3rd and 4th. This is the 3rd and this is the 4th. So their average will be 33. 10.5th observation is Q3. 10.5 means the average of 10th and 11th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the average of these two will be 50. Now we have to draw box plot. And make sure draw all the diagrams with pencils. Always use pencil for diagrams. Now how will you draw a box plot? This is so simple. Must label the horizontal axis. This is the first important thing. And you can start your horizontal line from 10, because the lowest observation of both the data is the lowest is 27 here and the lowest is 17. So you can start your box from 10. You don't need to mention 0 and jag line here. If you want, you can. Now, mark a dot. Mark the lowest observation. The lowest observation for physics is 17. This is the way to draw a box. This is 17. So mark 17 here, and this distance is 3 centimeter. So whenever we draw a box, we keep this distance 3 centimeter. This must be at least 3 centimeter. And this is the best way to draw a box plot. Always keep this distance 3 centimeter. The distance of this point from this axis must be 3 cm. This is 1 cm, one box, 2, 3. Now this is 17. The Q1 of physics is 28. Now mark 28 here. The distance of 28 from this horizontal line is 3 centimeter. Then mark median. This is the median. Then mark the upper quartile, and then mark the highest observation. Now make the box through Q1 and Q3. This is the box. This is Q1 and this is Q3. This is Q3 and this is Q1. Label the median. This is median. And when you will draw whiskers, make sure you will start whiskers from Q3 and Q1. The width of box must be 2 centimeter. This distance must be of 3 centimeter and the width of the box must be of 2 centimeter. These are the standards, and if you will use these standards, you will you will be able to make a proper box. See, this diagram is looking very good. This is really good. So this is 2 centimeter, 2 centimeter, 2 centimeter. The width of box is 2, and this whiskers part, this could be of 2 centimeter and could be of 1 centimeter. It's your choice. You have option. You can make this length as of 2 centimeter of length 2, or you can make this of 1 centimeter. I usually make 1 centimeter. So this is the box plot. Make sure these whiskers must not enter into the box. These whiskers must start from Q3 and Q1. And if you observe this box plot, see, median is close to Q1, so this is positively skewed. Now for history, you have to label, you have to mark the lowest observation, 27, which is 27 at 6 centimeter distance from horizontal line, this horizontal axis. This distance is 3 centimeter and this distance is 6 centimeter, the double of this distance. Now mark Q1, then mark median, and then mark Q3, and then mark the highest observation. So this is the box for history exam of 2 centimeter width. These are the whiskers. Now you have to compare these two. Their medians are same, so on average both students have got same marks, and their ranges, physics have larger range than history, so more variation in physics marks than in history marks. Physics marks are more spread out than history marks, or you can say more variation in physics marks than in history marks. They ask just one difference, which could be seen from the diagram. Stem plot. The lengths of the diagonals in meters of 9 most popular flat screen TVs and 9 most popular conventional TVs are shown below. Represent this information on a back-to-back stem and leaf diagram. This is the back-to-back stem and leaf diagram. This is the stem, leaves for conventional and for flat. So flat screen are here, conventional are here, and how to construct how to make this a stem plot. This is so simple. Just check the lowest and highest observations. The lowest observation is 0.65 and the highest observation is 1.07. So you just need to ignore the decimal. You just assume that the data is of like this type: 85, 94, 91 and so on. Just ignore the decimal. So write 6, the smallest observation 0.65, so write 6 here and 10 is here. 6, 7, 8, 9, 10. Now how will you make a stem for conventional? Now 0.69, so write 9 here. 9 here, let's suppose 9 here, then 0.65, 5 is here, 85 is here, 0.77 here, 0.74 here, 67 is here and so on. And at the end you have to write the numbers in ascending order. First write the numbers in the given way and then write the numbers in ascending order. We were getting a 975, so just erase 975 and write 579. Make sure your stem must be in ascending order. Ascending in this way, ascending in this way. This is for flat screen. And the key is very important. So 671. 6/71 means, now first explain this thing. This means 0.76 meter of flat screen TV. And this means 0.71 meter of conventional TVs. And you all know how to get median and quartiles. I'm leaving this part. Mean and standard deviation is simple. You know the formulas. This is the formula for mean and this is the formula for standard deviation. I have done this thing in my first lecture, measure of central tendency in a spread. So you can understand this concept from my first lecture. Now I will discuss more questions in my next lecture. An important advice for me and for everyone: be honest. We should be honest. Good luck and Allah Hafiz.